Hey everybody, it's Nick from Archangel Battery here. Back at you. Wanted to do another video. This time it's going to be a little bit different. I wanted to do a rebuttal video of Victron Energy's video on will a lithium battery burn up your alternator. So without further ado, let's get right to the video.
Hey guys, just want to say before we start the video, I'm going to be starting and stopping this video a lot and then discussing the points that they've just made. And I'm also only going to be discussing the main points that they've made. So if you want to see the full video in full context, please click on the link below. I'll have it included. And without further ado, let's get started.
For various reasons, charging a lithium battery from an alternator is not as straightforward as charging a lead battery.
Okay, just looking at the battery you have here, you've got what looks to be non-standard bolt-on terminals. I don't know if those are standard in Italy, but they're definitely not standard in the States or in any other country that I've sold batteries to. So I could see how if you had that style terminal, it wouldn't be straightforward. Here's the thing though, at least with Archangel, we have standard SAE and DIN terminals that we use for all our batteries. So they go straight into a car and you just clamp on. We're also going to have screwed on terminals for vehicles that take the bolt on terminals, very similar, like usually Chevy vehicles have these. I also want to note that the actual swap in of the battery is actually easier because it's a lot lighter. It's about 50% that of a lead acid. So you can just literally pull the lead acid out and then kind of with one hand reach over and put a lithium in. Super easy. I also want to note that lithium's voltage range is the exact same as a lead acid, which is why it's called a lead acid replacement. Lithium nominal voltage is 12.8 volts. Fully charged is 14.6. Guess what? That happens to share the same voltage range as a lead acid battery. It also happens to share the same max voltage range as an alternator at 14.6. It's absolutely fine to put a lithium battery with no modifications into a car. Just want to state one thing. One, this is not a real world setup. In a car, obviously you have an engine driving the alternator. Secondly, this is a bad setup for one specific reason. Without being in a car, you do not have a ground to the vehicle's frame. And thus, you don't have the gigantic heat sink that you normally would. Because that's exactly what the vehicle's frame acts like at that point. And it also adds a little bit of resistance. But moving on from that. Oh, I did want to note one real quick thing here. If you don't understand how alternators work, here's kind of a basic rundown, and you can see the alternator table that I've linked down below. It's for a Dodge Ram 1500. Look at the 220 amp version to follow along kind of with what I'm saying, but basically the alternator has a certain amount of RPM, and at that RPM it will put out a current. Most alternators, when you say they're rated at this rating, that's rating at full RPM. So a 220 amp alternator would be rated at the max RPM. In the case that I've linked, it's 8,000. So at 8,000 RPM, you're putting out 220 amps. However, that's only if you have 220 amps worth of load. If you do not have 220 amps worth of load, you won't put out 220 amps. Let's say you only had 100 amps worth of load at 8,000 RPM. I said 100 amps, right? Okay, yeah. If you only had 100 amps of load at 8,000 RPM, you're only going to put out 100 amps. You're not going to put out 220, even though you're capable of putting out 220. Just want to note that because that's kind of an important thing to understand.
Test is this 300 amp hour lithium battery. Although it requires a battery management system, as we are here and using it for tests, it's without one.
Okay, if it requires it, then it needs it. This is not a fair test. Battery management systems, and I don't know how Victron Energy's works, tend to protect batteries from overcharging by removing them from the charging path. So if the battery wasn't in the charging path, it couldn't possibly be burning up the alternator because it wouldn't be charging the battery. It's all important here. They needed to have included it.
We're making sure the lithium The next test we conducted was charging the battery at half the speed, 1500 RPM. Note that this is still above the typical speed of an engine running idle. This test is still pulling a similar amount of current, 65 amps, out of the alternator, but the effect of the lower RPM and therefore less cooling on the alternator is significant. Its temperature increased so much it started to burn the internal coil.
I have never seen this happen, and I've had lithium batteries in the car that I drive now for 3 years. And I've left my car at idle for a very long time. So I want to note several things. One, he never said in the video how long it takes to get to this point, and I think that's kind of critical because I've left my car running for like 30 minutes, so I mean, how long does it take to get here? Two, he's not doing this in a vehicle where there would be heat sinking, because the alternator wouldn't just sit there and build up heat, it would be dumping heat into the vehicle's frame, like I had said before. And three, I'm not sure I've ever read about this or even witnessed this online at all, and people have been swapping in lithium batteries into cars now for years. I mean, I'm not the only manufacturer who does this. I've never heard of this. If any of you have heard of this, please let me know in the comment section down below.
What we've seen is that indeed issues can arise when charging lithium batteries with an alternator.
To be honest, I think you've seen that because that's what you wanted to see, because you're trying to sell an alternator to people.
The major difference in alternator charging between a lead acid chemistry and the lithium chemistry is that due to the internal resistance of a lead acid battery, the charge current is limited.
Okay, several things here. One, with a BMS, as soon as it is charged, it wouldn't be in the charging path anyway, at least for brief periods of time, allowing the alternator to cool, even if that was the case for you guys. Secondly, it's not hooked into a car, so you don't have the heat sinking of the vehicle frame like you would in a real world circumstance. Three, as the battery starts to charge, it will build EMF and resist flow into the battery. If you don't know what EMF is, it stands for electromotive force. It can also be thought of as the voltage of the battery. So when you have a high voltage, you cannot push current into that high voltage. That voltage is going to resist current flowing into it because there's no potential difference. And what I mean by potential difference is this. If your alternator is putting out 14.6 and the battery has 14.6, you can't very well push current into the battery because there's no difference between the two. There's zero voltage difference between the two. So there's no way to do that. So most of the current is going to flow out to the loads, which, as I described before, are what limits the current flow on the alternator at a given RPM. So there's no way to continue to push current into a BMS anyway, even if it didn't have a BMS. By the way, I should note that Braille, and shout out to Braille, but they don't have BMSs in their batteries. They just have very well matched cells. So, and they've never had a problem. So I don't know, or at least I don't think they have. If they have, please let me know in the comment section down below. But yeah, I don't see this. Also, you know, I'd like to note that when a lithium battery charges up, at least to my understanding, again, correct me if I'm wrong, but the resistance increases as it charges on a lithium chemistry. So this may not be a completely accurate test. And I also want to note that alternators are very robust, and they have a factor of safety like anything else. My guess is it's greater than whatever the alternator is technically rated for, so you can probably run that alternator at even if it was to happen, you could run that alternator at greater than the alternator's output current is for probably short periods of time. They design them like that for a reason, because if you ever had a problem, you wouldn't want to just immediately burn up the alternator. Yeah, I don't see what they're talking about here. Let's get on with the video.
For lithium batteries. A lithium battery will also draw a high current at low speed, causing the alternator to overheat.
I don't know why it would. I mean, in theory, yes, the resistance will allow for double the current, but lithium batteries can also charge at much higher rates, so it won't damage the battery. But I know that you guys are actually saying that it's going to damage the alternator. I still don't see how that happens. Even at very low RPMs, say 1500, call that idle, I don't see how that happens. The most I've ever measured in a car is 80 amps, and that's what I've measured experimentally. And that's not more than the alternator can handle. I mean, typical alternators are rated for about 220 amps. I honestly, in modern day vehicles at least, maybe in an older car you could find one that was rated for 80, but even then, you're only ever, I mean, I guess at lower RPMs that could be the case, but you're only going to be there for a brief period of time. Even if you weren't, you still have the heat sink of the vehicle, and you have the BMS taking it out of the loop. I just don't see this being a problem, and I've never seen it be a problem.
Video is that many lithium systems disconnect the battery from the charging source.
Okay, so what this is typically is a load dump, and what that means is when you disconnect the battery from the vehicle, you can sometimes, you'll release the current in the coils, and what this causes is typically huge, a small spike in voltage, give or take. But here's the thing about vehicle electronics: they're very robust, and they're made to a certain standard, an automotive standard. They're designed to handle small spikes. So just disconnecting the battery from the load is not going to hurt things. Vehicles are designed to handle that, and they're designed to handle it very well. I do not see this being a problem, nor has it ever been a problem in any of the batteries that we've ever sold to our customers, at least not that I've heard of. I've heard of our batteries dying occasionally from different circumstances, but I've never heard of this.
Once fully charged.
Okay, and this is where they just get into their sales pitch for their stuff. So I'm probably going to end the video here, guys. Like I said, if you want to see the video in full context, please see it below. And if you like this content, please give me a like, comment down below, and subscribe to the channel. I'm going to be bringing a lot more content. I hope to do some stuff on machining in the future. I hope to do some stuff on SolidWorks tutorials in the future, and also continue to talk about batteries. I might do a little bit of Bitcoin stuff too, and we are accepting Bitcoin for our batteries when we actually have our product in the upcoming months. And I hope to see you guys in the next video. Thanks for watching.